In this video, we are going to talk about the discriminant. The discriminant is something that can kind of help you figure out what your graph should look like quickly, tell you how many real solutions or imaginary solutions you're going to have quickly without necessarily solving the whole thing. So the discriminant is b squared minus 4ac. From the quadratic formula, it's just a chunk of it. That was a terrible 4. 4ac over 2a. It's just this piece here. It is not any of this other stuff. Okay, it's not even the x equals. No square root in here. But there are going to be 4 outcomes that are going to happen, potentially. If that is a perfect positive square number, you are going to have 2 real rational numbers. You're going to have x equals 5 and x equals 7 or whatever as your roots. If it is a positive non-perfect square number, meaning square root of 5 or something, so square root of 5 in the quadratic formula, I should say, then you are going to have 2 real irrational roots. Okay, you're going to have x equals negative 2 plus square root of 5 for plus or minus square root of 5 for your roots. They're still going to cross the x-axis, but they're going to be between your integers. They're not super nice numbers. If you get your discriminant equals 0, honestly, this is what I hope for every single time. I cross my fingers, usually let down, but it is what it is. If it equals 0, you're going to have 1 real rational double root. What that means is, if I were to sketch a picture quick, your parabola is going to touch the x-axis and bounce away. I'll say x equals 1. You still have 2 solutions. They're just sitting right on top of each other. Okay, that's all that means. I hope for that because then it's simplifying a fraction. I don't have to worry about simplifying any radicals whatsoever. And if b squared minus 4ac, if the discriminant is negative, you're going to have 2 imaginary roots. You're going to have 1 conjugate pair, but 2 imaginary roots. Your graph just didn't cross the x-axis. So for these ones, it doesn't say to solve. It says describe the solutions to the given quadratic equation. If I knew exactly where they were, I'd be able to do that fairly quickly, but I don't know where they are, so I'd have to find them. That's kind of a whole process. I don't really want to try to factor this thing. I don't really want to try to do the quadratic formula or complete the square or any of that. So excuse me, A is 4, B is negative 10, C is 3. I'm going to have negative 10 squared minus 4 times 3, which is 100, minus something less than 100. Okay, it's going to be 4 times 4 is 16 times 3 is 48. I don't really care that this number is 52. I just know that this is a positive number, so I know I'm going to have real solutions. The fact that it's 52, all that tells me is 52 is not a perfect square. So there are going to be 2 real irrational numbers, irrational solutions, roots. Okay, I said solutions, roots, same thing. I didn't have to go through the whole process of finding them. I just know that they exist and that they are real irrational solutions. If I had done the quadratic formula, I would have ended up with x equals 10 plus or minus the square root of 52 over 8. And then I'd have to simplify that fraction and worry about simplifying that radical if I could. And that gets really annoying. So sometimes it's best to just want to know what kind of solutions you have. So I don't need to go through that whole process. In number 47, I'm actually going to do this twice to see that we get 2 different methods that give us the same answer. So first thing is, okay, if A is 6, B is 8, C is negative 12, it's going to give me 8 squared minus 4 times 6 times negative 12. Immediately right now, I know that I'm going to have real solutions. I know this because 8 squared is 64. That first part will always give me a positive number. But the second part, 4 times 6 and 12, but I have negative times negative, it's going to give me a plus number of any result here means I'm going to have a positive number under the radical. In this case, it's 288. So I'm going to have a discriminant of 352. Okay, some people say D equals, I'm not a huge fan of that myself, but the discriminant is 352. So in my calculator, quick, I do square root of 352, gives me a decimal, and then I get to say there are two real, since it was a decimal, irrational solutions. The biggest giveaway is based off of this symbol right here. If it's a plus, you will always have real solutions, no matter what. You have two of them. They just might be rational or irrational. If it's a minus, you might have 0 for your discriminant, which would give you one real double root, or you'll have two conjugate solutions. Okay, just kind of depends. Now, I said I was going to do this problem two different ways. Here's the other way. 6, 8, and 12 are all divisible by 2. If I divided both sides of my equation from the beginning by 2, I would have had 3x squared plus 4x minus 6 still equals 0. This time, a is equal to 3, b is 4, c is 6. So 4 squared minus 4 times 3 times 6 becomes 16, minus 6, excuse me. 16, 4 times 3 is 12, times 6 is 72. This is going to give me an 88. They're completely different numbers, but they give me back to the same idea. Okay, I simplified the numbers a little bit, made my calculations a little bit easier because everything was had a common factor. Now, in your test, you're going to have to pick the most efficient method for solving a quadratic equation. I gave you a little table here at the bottom. Factoring, if you can factor, that's the when to use it is the short answer, is if you can factor. If there is not a constant term, you will have factoring as an option. X just might be your greatest common factor. If you see a difference of squares, you have to identify that, use that. Or if your discriminant is a perfect square. Okay, both of the ones we just did, our discriminant was not a perfect square, so we had irrational solutions. Factoring would not have worked. If our discriminant ended up being a 16, that means we could have factored. You're going to solve by square rooting if there are no linear terms. So, okay, I should have specified this constant has no x, no linear term. I don't like how I wrote that no x. No x-less term. So I'm going to write no plus a number term. Here, there's no x term. For linear term, linear meaning that x has a power of 1. And if it's in vertex form, you're going to use a square root. You will see an x term looking thing because vertex form is y equals a x minus h squared plus k. Okay, there is an x term there, like you will see this x, but it's being squared, FOIL, it gets taken care of with the square root method. You're going to complete the square if a is 1 and b is even. If it's not, you can manipulate it so those are kind of true, at least the a is 1 part is true. And the quadratic formula is the I'm not sure what to do, throw this thing at it. You have to make sure it's in standard form for this thing to work. Have a great day, everybody.